Building Design Committee. I'd like to welcome you to the third lecture of a six-part lecture series on sustainable design solutions for the built environment. The series is presented by the Green Building Design Committee, a subcommittee environmental performance advisory committee, or otherwise known as EPAC. The Green Building Committee has teamed with facilities planning, campus planning, landscape architecture and regional planning, architecture and design, the Historic Preservation Initiative in the College of Humanities and Fine Arts, and the Environmental Conservation to present this series with the goal of expanding our collective knowledge and commitment to sustainability on campus. So I'd like to thank all of these cooperators for helping make this effort possible and support in bringing the lecture series. Particular thanks goes to our Green Building research team, which is Lawson Wilson, Katrina Spade, who is in the back of the room now, along with Bill Stanton and Catherine McCusker, who have, for all of their efforts in organizing the series and all the details it takes to organize an effort like this. So a lot of work has gone into this, and I hope you enjoy it and you learn something from this lecture and future lectures, because we have 3 more after today. And please join us next Friday for a talk by Gene Caroon, an architect of Goody Clancy Architects in Boston. And the lecture next week is entitled Sustainable Preservation. Her lecture is at 12 o'clock noon next Friday, October 27th, in this room. So I hope to see you there. It should be a good one. Today's lecture is hosted by David Damery, who is a program director of Building Construction Technology. And without further ado, I'm going to introduce David, and he will talk a little bit about the lecture tonight. So thank you all for coming.
Thank you, Jim. Welcome. It's good to see almost a full house. First, a couple of administrative details. Please silence your cell phones. Today's lecture is available for continuing education credit for both AIA and USGBC through their self-reporting system. Bring that to your attention. You have a survey on your seats. I'd like you to take a few seconds to fill out question number 1. You will be graded on this. And at the end of the lecture, you can fill out the rest of them. But take a few seconds right now to fill out question 1. Any of students in my built environment class, BCT 191A, who are here today and have not yet signed up on an attendance sheet, I've got one way in the back to the left of the doors. If you would like to find out about future events sponsored by the Green Building Committee, please leave your email address on the survey. After the lecture, you can complete it, and one of the student interns will take it from you on your way out. This lecture is being recorded, and it'll be made available through the facilities planning website. And now I'd like to introduce today's speaker. Louis Capozzi has been the manager of facilities engineering at the Genzyme Center, a USGBC Platinum-rated green building, for the past 10 years. During this time, he's been involved in all aspects involved with the maintenance of Genzyme's corporate headquarters, including all plant utility systems, electronics, building management systems, refrigeration, electrical, air, water, and plant steam in strict accordance with standard operating procedures. A key aspect of this job includes preventive and corrective maintenance of the facility while simultaneously making continuous improvements in those processes. Louis manages 10 crew members. He is responsible for hiring new team members, training them to meet the needs of the department, and to ensure compliance with all GMPs and SOPs. Louis also works collaboratively with other facilities managers across Genzyme's businesses to identify and improve maintenance issues. Louis was a member of the commissioning team that developed Genzyme Center. The project scope included the inspection and testing of all mechanicals, Andover building systems, steam, kitchen, heliostats, sun shading systems, water collection, steam absorption chillers, and cooling towers. I present Louis Capozzi.
Good afternoon. I'd like to start off with a short little take film, about 6 minutes. It describes the building and the way it was when we first opened up in November of '04. It's pretty interesting and give you a scope of what's inside the building. If you could start, that'd be great.
Can you get the lights?
Think about how to make that an interesting experience, an important experience, a learning experience, an innovative experience. So we asked 5 architects to give us some proposals. And we said, listen, it has to be consistent to our purpose. And our purpose is to innovate. Our purpose is to create new standards.
The design of this building has been focused from the outset on the people who work, who live in these buildings. It is our conviction that since individuals spend a significant part of their life at their working place, these spaces should be
And a vision of the future inside the office of a local company that's all about the environment.
Step inside the atrium of the new Genzyme Center in Cambridge, and you're greeted by cutting-edge design. But it's what you don't see as easily that makes this structure stand out.
Caught in just the right light, Genzyme's new Cambridge headquarters literally sparkles.
It's almost like still being outside. When you come into the atrium, you just have this sense of you're not inside a building.
From running water to exotic trees, the designers turned the building inside out.
There are basically 18 indoor gardens. Instead of putting landscape around the outside, we pushed the perimeter of the building to the perimeter of the site and brought that environment inside in the atrium.
For their new headquarters, Genzyme, a biotechnology company, wanted cutting-edge, recycled innovation.
There's a good percentage of recycled content in almost all the materials used in the building. The framework has aluminum extrusions which have recycled content. Drywall, ceiling panels, wood materials have recycled content.
The centerpiece of the building is the light that filters down, but for more on that, we have to go all the way up.
These special mirrors called heliostats are mounted on the roof, and they're programmed to track the path of the sun throughout the day. They track the sun and reflect the light to another system of mirrors mounted on the other side of the roof. And then those reflect the light constantly down into the atrium throughout the day.
Like diamonds in the sky, the atrium's giant prism mobile catches that light, splashing it onto the walls and floors below. In turn, the building becomes a stage for a troupe of dancing rainbows, competing with natural light from the exterior.
The way that the offices are designed is offices on the exterior of the building have glass walls, and then the light enhancement system, which includes blinds that reflect light into the interior space. The glass walls just permit the light to just permeate right into the heart of the building.
There are enviable Boston views looking outward, and looking inward, the building opens into a theme of glass transparency.
People are using less voicemail, less email, they're connecting with one another face to face. It's just a very, very unique environment to work in.
Encasing the building is a loggia, an outer shell that holds heat in the winter and cool air in the summer. It even allows access to fresh air. From top to bottom, this building is all about conservation, saving on energy, electricity, and water. At Genzyme, the building of tomorrow is here today, made from the stuff of yesterday.
I express appreciation for the responsibility and commitment which said that's a brownfield site next to a power plant, but we're going to build a world-class, best in the world green building there. Think of that. That's commitment. That's responsibility. Those are the kinds of attributes that I think make Genzyme a great corporation.
This is the right spot for us. And brownfield, if you think of it, is an extraordinary opportunity to do something right. Because when you build a plant like Alston, you build an engineering marvel. When you build an office, you have to think about how to make that an interesting experience, an important experience, a learning experience, an innovative experience. And all of this, of course, happens through people. It's all a matter of people. So the building has to work for the employees. It has to be inviting for the employees to work together with full regard of their privacy as well. Because indeed, if we are successful together, we will make a difference. We will make a difference to all our lives, to all of the lives of people not here in this space today. And that is both a responsibility and a tremendous exciting thing to work on together. So I appreciate you all being here. I am grateful for all of you who have been so tremendously helpful to getting us to where we are today. Thank you so much.
Thank you. I apologize the way I'm dressed is, number one, is that I went to the hotel and they had a bomb scare. So I wasn't allowed to go in until later. And one of the reasons why I wanted to show the film first is that just to give you an idea of what Genzyme Center is like and what we go through every day. The building itself is, what's that? We have a crew of 11 people that run the building. We specialize in electrical, HVAC, plumbing, carpentry. The men themselves make the building run efficient. The concept of the building. The agenda we're going to go through today is that the way the building was set up, the history, decapitation, the environmental rating, natural light, building performance, and continual improvement. Genzyme itself was reflected on the core values. As you saw in the film, the gentleman that had sort of an accent was the CEO. He is no longer a CEO anymore. We were bought out by Sanofi Pharmaceutical, so he has actually left the building. The basics of the building. The architect was Behnisch, the gentleman that you saw at the beginning. Turner Construction, Lime Property was developing, and the square footage was 350,000 square feet. Of that 350,000 square feet, 70,000 is the atrium. The cost of the building cost $140 million to build. $107 million was just for the construction, and the rest was tenant fit out. When we were building the building, we were at the cutting edge of green technology. We had no plans of going for USGBC. They had approached us. We had no idea what was going to go through. At that time, when we went for all the points, the paperwork was about this high. Now it's very simple. You go online, fill it all out. It's located at 500 Kendall Street in Cambridge, Mass. It's right next door to like a electrical plant. If you can see the large bellows there on the right, back in the 50s and 60s, those were all made of rubber with heavy weights on top of them. As they filled them up with gas, the weight of them would push them down and push the gas out to all the pumps. It was very different. Since then, they've tore them all down, and now it's where we have Genzyme. When they had that contamination, this is what was there in the ground. And from what I understand, they poured concrete in the ground, let it harden, and took out the waste. By doing that, being a brown site, what we have there is a series of tubes that run under the floor that actually get sucked up into a vacuum pump. Vapors go through a series of carbon beds out in the atmosphere. This is monitored at least once a month. The carbon was supposed to be changed every 8 years. We just had it tested, and they said it was very, very little. And what the contamination on the ground was, basically was they used to store the coal there for the plant next door. So it wasn't really contaminated, but it was contaminated. The development for the property itself, they paid for 10 acres, $21 million back in 1991. The cost of this hard and soft cost to clean the whole area up, by the time they even started building the building, it cost them $198 million until they start putting the foundation in. We received the Platinum Award. As a lot of people would say, it's a hubcap on a wall. We had a little problem that we were going for gold, but toward the end, the CEO wanted to get the platinum. And the big argument was about the CO2 sensors. They told us we needed 9 when we were building the building. We put 9 in. When we went back to file, they said we needed 11. So after about $5,000 later, we got our point. We ended up with a platinum rate. So just keep that in mind if you're going for a LEED certified building. It has the inaugural low air pollution, bike space, electric vehicle hookup, carpooling, near public transit, community friendly, underground parking. The roof itself is a green roof. We have rainwater collection tanks. Waste steam. We have the electric plant next door. The electric plant generates almost 500,000 pounds of steam in the course of one day. They can only sell 250,000 pounds. The other 250,000 pounds are being cooled off by the water. They suck in 1 million gallons of water a day and pump it out to where the Museum of Science is. If you ever drove by there and never seen the boats and never frozen, that's the reason why. The solar panels, we have about 2,800 square feet of them. They give us between 1 and 13% electricity. We don't put it back into Genzyme, we sell it back to the grid. We did a little survey on that and a little math on that. For our return on investments, will probably be 100 years. We have the operable windows. I'll explain about them in a few slides. Irrigation system for the planters. All have soil sensors in them. They all water themselves. They work great. Rainwater collection tank. We collect 1,000 gallons of water. We take the water from there and we put it into our tower water. During the course of a real hot, humid day, we'll probably evaporate about 22,000 gallons. The low flush waterless urinals, great at the beginning. They told us the fiberglass would absorb the smell, but after 5 years, we ended up changing them out to porcelain. It does say we save 525,000 gallons per year. I don't know. I don't really stand behind that because it's not true, truthfully. The water feature holds 1,800 gallons of water. When we were first building the building, they did the value engineering. They took out the humidification in the building. The first year we were there, the wood started cracking. So they come up to us and ask us, you know, what can you do to make the building more humidity in it. So we put our heads together, and what we do is we heat the reflecting pond up to 98 degrees between the month of, I think it's October till about the end of April. And that humidifies the whole building. I get yelled at because we used energy. We take our condensate water that's from our steam, put it into a heat exchanger, and heat the water up for that. And they told me I was using energy. The materials used in the building, it is all recyclable material. Believe me, you see where we're trying to put things together. Things do fall apart pretty easy. Recyclable is great, but it's not the top of the line. We'll talk about the filigree slab, which was pretty good. The environmental, the building itself, see if my people are going up and down the elevators, yep. The building has 800 operable windows. Between the month of May and late October, the time between 10 p.m., 4 a.m., temperature outside equals temperature inside, wind speed is less than 10 miles an hour, humidity is at the same level, all the windows will open up and flush out. The works pretty good. Last year we did it 14 times. In fact, on the way here today, we had an issue last night that they all opened up, which they should have not, because we had the temperature set for 74 degrees. So there's probably a glitch in there, software end of it, and we'll have to look into it. We have a BMS system that covers 40,000 points. We cover all the controls, all the smart sensors, all the windows, even the blinds, and we monitor the heliostats. The building itself is based on foot candles. A foot candle is a measure of a square foot. How many candles can you get into it? An average office building has 25-foot candles. This building has 46-foot candles. One of my biggest things is that during a real bright sunny day, the emergency lights are on. Why? And I talked to the fire department, I talked to the building inspector, electrical inspector, and they said, well, that's the way it always is. If I can get them to shut them off, it would probably save 2 floors of electricity. That would be a big savings. We also have a great cafeteria up on the 12th floor, which to everybody else it's great, but it's a nightmare to us. Right below the cafeteria is the boardroom. And guess what happens when they have leaks? Constantly up there. The lighting, as far as we talk about the heliostats. The heliostats follow a program from Germany, follow the sun going from east to west, reflect off to 63 stationary mirrors down to 1,050 prisms down to 768 chandeliers. These are the prisms that we had a little problem about a half a year ago. Each one of these little prisms are held in by 4 little set screws. We come in the morning, and believe it or not, one was just about falling out. So we had to go up there, turn them all over, and tighten every single one of them. Again, a day in the Platinum building. Chandeliers. We have 16 chandeliers. Heaviest one, 250 pounds. Lightest one, 75 pounds. Last weekend, we just got done cleaning them. What we do is we go up above the prisms, tractile, 2 men go out there, hook it onto a winch, lower it down 200 feet, and put it into a big tub. When we first started out, we thought we were smart. We were using kiddie pools. As it was coming down, it was slicing all the, so we had water everywhere. Since then, we devised this real nice washer tub. The light wall, a lot of polishing in this building, a real lot of polishing. If you can see it set way in the back there on the top there, it's light walls that were supposed to be done by Warama, who built the blinds, but we ended up Valued Engineering, get an American company, and they don't work as well as they should. The blinds, we have 1,030 of these blinds. They're all based off sunlight, north, south, east, and west. Anything above 59.7 degrees will reflect the sunlight or the heat out, let the sunlight in. By saying that is, we have 2 steam absorption chillers, 480-ton chillers. The building was designed to run both of them at about maybe 50-60%. One day we had a problem with the steam. Shut the steam down. As we walked by, we noticed that we're still using 5,000 pounds. Make a long story short, the steam meter was too big for the building. Got everything straightened out. We ended up getting a check back from the steam company of $460,000. But now we had to sit down. Why did we over-engineer so much? We never took consideration of the blinds, how much they save the energy and how much they let the heat out, especially during the summer months. So that was a great learning curve. Now where it stands, we have 1 whole extra chiller that we go back and forth, alternate every other month. This is the Blue Nude. The goes up 12 floors. It's all painted on all the floors, all the way up. I've tried to put this together. Somehow you just can't do it. I think it's missing the head someplace, but it's, if you ever get the Genzyme, you'll look up and you'll see. I mean, how does it even, just thought I'd throw it in there. This is the construction site. One thing I wanted to show you is that these pilings, there's 98 of those pilings that were put in. If everybody knows about the history of this area itself, Beacon Hill was taken down. This was all backfilled. This was all marsh. Put all the dirt in there. So the building does not have a basement at all. This is the building as it's being built. I just want you to show especially the top layer where you see the styrofoam and you see the facade just attached to it. The way the building was built is what they call filigree. And the way that's done is that they have these slabs of concrete that are about, say, 30 feet long, 4 feet wide, about 4 inches thick. Laid them down. On top of that, they had 4 inches of styrofoam. In between the styrofoam, they put all the supports and the cables. By doing that, they saved the building about 250,000 square feet of plywood for not building forms. And also, building this size would take about 1,800 tons of steel, only took 1,300 tons of steel. Here it is again in a closer look at it. The slabs are great, but you know, in facilities or in engineering, you know, they always put the outlet in the wrong place on the floor. So in order for us to drill a hole, we have to get an x-ray because they have tenders going through them. If you snap a couple of those tenders, the planks will actually collapse. So it's no drilling. Mechanical room, the redundancy we have, these are actually heat exchangers that we take the condensate return, goes back through these heat exchangers and we heat the building up with that with the water. A couple of the guys, these are the chillers, 480-ton chillers. This is our rain collection tank. We collect 1,000 gallons of water in this. Last year, we were a real hot, humid day. We have 2 22,000 CFM makeup air units that supply to 560 fan coils. It's a constant fresh air coming in. We put a bucket under the condensate return, and 5-gallon bucket took 1 minute and 30 seconds to fill up. So from there, we put 2 pumps in, and we pump it into this. The 560 fan coils are all 4-pipe system. You could have heating and cooling in either office if you want. These are the guys again. We had a roof leak, so we sent them up there to fix it. This is our solar panel collector that actually changes DC to AC, and we monitor that very closely. Not that there's much in there. These are the exhaust fans. We have 4 33,000 CFM exhaust fans. When the building goes into fire alarm mode, all the blinds go up. We have 68 garage doors that close down. These kick on, suck all the air up. The first year we were there, a lovely security guard decides to put a popcorn in the microwave oven. Pulls it out, sets off the pre-action system. since it's a computerized building, the fire department shows up. It was, I don't know if you'll never forget the date, it was December 29th, 2 o'clock in the morning, 0 degrees out. When I got there, I set the whole building up, everything was fine. I come in the next morning at 8 o'clock, killed $35,000 worth of trees, because it was 0 degrees out. So there was at Genzyme, you'd say that the gentleman got a promotion, but that structure in the back there that looks like staging, that's supposed to represent wind seals heading north. Serves no function. It's actually falling apart. I have a proposal in. I'd like to take it down and put 4 windmills up there. Can't generate any electricity, but I think it'd look pretty neat. The lights are out on the top. Safety won't let us go up there, so it's one of those. Okay. Here they are out there working on the tractile. The above the prisons, the loja space that they were talking about in the film there. It's about a 2.5 foot space, and it's double facade, 2 layers of glass, 1 single glass. The original content of the building was that it was supposed to be around the whole building on every floor. Facing the south side would heat the air up and travel all the way around the building. But what ended up happening is the fire department came in and said that every 100 feet you have to build a wall. So we scratched that, and we only have 38% of the building. Here they are again. They were at the time changing the Allen screws. This is a good picture of the chandeliers. It's just a piece of plastic. It has ribbed on one side, flat on the other. Each one reflects sunlight to certain areas. A good picture from the bottom. I know that was quick, but any questions? Yes.
You had mentioned at least once that you couldn't stand behind savings. Are you doing anything like building-wide to measure the performance of this building in terms of energy, what you're actually achieving in energy savings? I mean, from building-wide, in other words, to answer the question, a platinum building, is it worth it, what you went through? In terms
good
of
question. What he asked is the building really performing the way it's supposed to? The building right now is performing much better than it started out. We started out the building, it was designed for 2.0 watts per square foot. We have it down to 1.2, so we're able to save energy there. Water consumption, when they come out with that number, I still can't figure out how they try to figure that out, but we're saving on water, but not as much as that. I don't know where that figure came from. I mean, I've questioned the environmental people about that. Are we saving on energy use? Yes. Last year, we had a company called Symmetrics come in, energy audit company. They came in and they said that we like to do your building. I said, well, it's a platinum building. What can you save? We gave them a month. They came back and they said the most we can save is maybe $40,000, $45,000, maybe a little bit more. And I said, well, I'll tell you what do you think we can do? He says, well, we have all these ideas about, you know, going to the deadband, going this and that. So you just tell me what you want to do, and we'll do it with our programming on our BMS. By the time we get done, we save now almost $195,000 a year. Changing the light sequences, the shutting down the air handlers more than we have before. The fan coils are going off, they're not on as long. The lights, a lot of the lights, there's no reason why we have the lights on at 6 o'clock in the morning till 9 o'clock at night. People at Genzyme don't show up at 10, they leave at 4. So it's, we cut back on that. I hope that answers your question. I do have a lot of numbers for you if you'd like them. I can show you percentage-wise what we've used at the beginning compared to now. We've cut our steam cost down more than half. And because of that, you know, that extra chiller. Yes?
On the construction level, the crews like working with this technology more than like the regular construction materials?
Interesting question, the construction workers. I was involved in all the commissioning. I was involved with all the unions there too. What it was, again, it was cutting technology. And they couldn't understand how you put blinds in and how they work by themselves. It was a learning curve for them, a big learning curve. The ones I think should have gone to school more is electricians. I mean, they should have controlled the wiring a little bit better. We're in the process now of changing a lot of those things. But yeah, a lot of the good old ways, they do it that way, but now it's, you know, new technology, you gotta step up.
Do you find that having this facility is a good way for you to attract people on your staff? Are they excited to be operating a high-performance building like this?
They might say no, but what it is that we pick the top of the best, and we put them into our crew. And they all specialize in a certain area. And they take pride in what they do. They really, the crew, it's 11 people in the whole staff, but there's only 7 of them that are technicians. And they run the building really well. As I did a tour for Columbia University, and the lady said, this is like a living organism, and you have to keep it all going at the same time, which is true. You take us out of the picture, and you know, things may run good for about a week or two, but then you'll have issues. That I promise you. Down the back there.
You said that the building was controlled by an automated system. How much control does the occupant have of the lights, the windows, shades?
Very good. One of the green points is that you have to have each individual control their own thermostat, windows, blinds, and we do have that capability. Each person can sit in their office at 46 inches out and look out the window. It's one of the criterias. But they can control their own thermostats, their own blinds, and their own lights to a point. The reason why I say that, we have the smart sensors that go between 68 and 76 degrees. After a lot of emails back and forth and girls screaming, we maintained the building at 74 degrees. But at 10 o'clock at night, even if you set it for 65 or 76, it goes back to 74 degrees. And same thing with the blinds. You can walk over to the blinds and raise the blinds up, but you can only do it for 1 hour. At the beginning, everybody was raising the blinds up and they were up all day. We said, that doesn't work. So we put a program in so it shuts down every hour. But it's, as far as the employees who work in the building, they did a survey and they say there's less than 1 sick day per department per month. So it's really low. Yes, sir.
So other than the initial screaming, what are the things that the occupants complain most about, and what are the things that the occupants seem most pleased about?
The biggest thing they complained about was when we first moved in, we were spending $1.6 million for coffee. We cut it down to $800,000. They were complaining about that. We gave them different tastes. But really, a lot of the occupants don't complain that much. There really isn't that many complaints. Once in a while, we'll get somebody that's really cold, you know, in the dead of the winter. She's sitting in a tank top. I mean, use your head. Or another one is that the on the loggia doors or the windows, we have these magnets. If you open them, they'll shut down your HVAC and freeze your lights. So if you leave that night, and we don't pick it up on our alarm system, they'll come in the morning and say, we can't do anything. And the first thing I'll ask them, close your window or lock your door. But it's very few, other than, you know, they want everything clean, they want everything done for them. And if you saw in the video, there's a lot of open space. Genzyme encourages everybody to have a meeting in an open space. So there's big demand for that. A lot of arguments about the conference rooms too. But otherwise, everybody's happy. We do have a program every, I think it's every 4 or 5 months. We'll move a department out and bring another department in. And just to get that sense of living in a green building. Anything else? Over there. The cost per square foot. Cost per square foot? It's probably about a little bit over $400 a square foot to build that. And it's just an office building. They said that the size, what we paid for this building, you could have built a 22-story building. And again, this was back in 1999, 2000. So the Coroma toilets were toilets we have for the women's room are 1 and 2 buttons. We had to buy them from Australia, so we paid top dollar for them. Now you can just get them right in any local hardware store or plumbing supply. Same thing with the waterless urinals. We had to fight the plumbing department to put them in. They said no, they said no. Now they're right around the corner, get them anywhere.
So your team's mission is to operate the building. Is it also to save as much energy as you can, or are the two things the same, or?
Well, one of my biggest things is we have a staff meeting every Tuesday. They're all happy today I didn't have one. But I try to push in ahead. How can we make it better? Even though it's running perfect, it has to be a better way to do it. So we're always coming up with constant ideas. Out of every 20 of them, maybe one of them will stick, or the other ones will just go to wayside. We have another one now that I just started thinking of is the fan coils. We have 3 speeds on the fan coils. We run them at low speed at all the time during occupied mode. An architect came in and said the air in here is delicious. But what I want to do is that if we have a dead band and you don't need it, shut the fan down. We started trending it, and it actually crashed our VMS system because it was too much information. But I'm thinking, I don't know if it's going to work or not. But we do a lot of things that sometimes they work, sometimes they don't.
As architecture students, a lot of times we're taught all these sustainability things to put in. And you mentioned the toilets, the fiberglass toilets. Is there anything that you would recommend not to do with your building that just basically might sound good, but just does not work?
Where would you like to start? No. The waterless urinals, I think, are a big upset. One of the things is that it's based on how many times you use a urinal. You're supposed to change a little cup in it. But we're finding out that even after a month or two, what happens, the salt from the body plugs the line up, solid. We physically have to take it off the wall, and we have to snake the whole thing. My idea is to put a water line, just let water drip down on it, but they won't let me do it. If I was to do it again, I would have probably gone to a different type of waterless urinal. In fact, we built a Lab 21 in Framingham. We didn't put them in because of that reason. The other thing too is the glass. There's more. We have, like I said, it was almost 8-point-something square acres of glass. It has to be cleaned. One of the biggest thing is, my pet peeve is you got to change filters every 4 months. Sometimes if they go by, you'll notice it on the glass. Everything gets dirty. Big upkeep. I mean, there's a lot behind the scenes that go on.
What are you cleaning glass with?
What do we clean the glass with? I guess it's Windex. I mean, I haven't really, yeah, but it's true. Like the chandeliers, when we dropped them in the first time, they told us we couldn't use anything but that spot-free, which I thought, where am I going to get that? So we went up to the kitchen, we took it out of the dishwasher, a gallon of it, just put a little cup in, and they come out great. Didn't know anything about it. We have, when we do it too, we drop it down into a tub, and I have 6 cleaners coming. I have them wipe down each one of them, and they wear gloves, just to make sure that they don't scratch anything. Not that anybody would see it.
Besides the building being like eco-friendly, you have like the office supplies and necessities like that in the kitchen. Is everything else trying to be as green as possible?
They're trying to be. I mean, we go through more paper than you wouldn't believe, but it's, it's part of the course I have in the business. The kitchen is really eco-friendly too. Everything is recyclable, especially the trays. We don't have any silverware at all. And the big concept with that is that if we put a dishwasher in and we had to wash all the silverware and the dishes, it would cost more money. Cheaper to throw away the styrofoam cups and the trays than put a dishwasher in. they put some thought into it, but they made the kitchen, they made it about the size of a closet. And it seats 125 people up there, and everybody goes up there at the same time at 12, and everybody's waiting in line. So,
Did you do anything for acoustics, or how does the building operate acoustically, given how many people are in outdoor spaces, or open spaces and stuff?
Good question, the acoustics in the building. They had a specialist come in to design it. And what they did is that you can actually stand on the first floor, someone on the 12th floor, and if you shut off the water feature, you could talk to them without yelling. The water feature gives that background noise. It's that soft. But once that shuts down, every once in a while we have to do a maintenance on it during the day. Phone starts ringing. What's the matter? The building falling apart? The day we had the earthquake, oh boy. The whole building was designed to sway 2 feet either way, which it did. It really moved, yeah. We just found a cracked window. I don't know if it's because of that, but yeah, the heliostats. I was up there one morning and looking up there, say, why is there a crack in that? Go up and look at it. A hawk flew into it. So it's a mirror. You think you could just get a regular mirror. No, we had to order it from Germany, $9,000 later, and put it in. That's the things about all the green technology. You know, if you're going to buy something smart. Don't buy something they don't make anymore. We're finding a lot of that, especially in this building. We have over something like 30,000 square feet of carpet. So it's starting to get worn down. 8 years, right? They don't make it anymore. So now we have to go out now. Do you decide to change the whole building, or do you do floor by floor? There's a cost that we didn't even think about. Little things like that make the day interesting. Anything else? Good.
Thank you.
Okay.
All right, thank you.